Security architecture resilience refers to the design and implementation of systems and networks in a way that allows them to withstand and recover quickly from disruptions or attacks. This includes redundancy, fail-safe mechanisms, and robust incident response plans. By building resilience into the security architecture, cybersecurity teams ensure that even if a breach occurs, the impact is minimized and normal operations can be restored quickly. Redundancy strategies are essential to disaster recovery and business continuity planning. These strategies include continuity of operations planning, which involves developing processes and procedures to ensure critical business functions can continue during and after a disruption. Let's look at some of these strategies. High availability, or HA clustering, uses redundant systems that can automatically take over applications in case of failure, minimizing downtime. High availability is crucial in IT infrastructure, ensuring systems remain operational and accessible with minimal downtime. It involves designing and implementing hardware components, servers, networking, data centers, and physical locations for fault tolerance and redundancy. In a high availability setup, redundant hardware components, such as power supplies, hard drives, and network interfaces, reduce the risk of failure by allowing the system to continue functioning if one component fails. Servers are often deployed in clusters or paired configurations, which allows automatic failover from a primary server to a secondary server in case of an issue. Power redundancy ensures critical infrastructure, such as data centers, has backup power sources to continue operations during an outage. All types of computer systems require a stable power supply to operate. Electrical events, such as voltage spikes or surges, can crash computers and network appliances, while loss of power from undervoltage events or power failures will cause equipment to fail. Power management means deploying systems to ensure that equipment is protected against these events and that network operations remain uninterrupted or recover quickly. Vendor diversity is essential for several reasons, offering benefits not only in terms of cybersecurity but also in business resilience, innovation, and competition. Relying on a single vendor for all software and hardware solutions can create a single point of failure. The entire infrastructure may be at risk if a vulnerability is discovered in that vendor's products. Vendor diversity mitigates the risk associated with vendor lock-in. It ensures that an organization's operations aren't solely reliant on one vendor's products or services. Diverse vendors bring different perspectives, ideas, and technologies. Vendor diversity promotes healthy competition in the market, which can lead to better pricing, improved product features, and higher quality customer support. Different vendors offer unique solutions that cater to specific needs, and having a diverse vendor ecosystem allows organizations to choose the best fit for their requirements. Vendor diversity helps spread the risk associated with potential product or service failures, security breaches, and other issues. In some industries, regulations or standards may require organizations to maintain vendor diversity to ensure compliance and reduce the risk of supply chain disruptions or security breaches. Defense in Depth is a comprehensive cybersecurity strategy that emphasizes the implementation of multiple layers of protection to safeguard an organization's information and infrastructure. This approach is based on the principle that no single security measure can completely protect against all threats. By deploying a variety of defenses at different levels, organizations can create a more resilient security posture that can withstand a wide range of attacks. For example, a defense in-depth strategy might include perimeter security measures such as firewalls and intrusion detection systems to protect against external threats. Organizations can implement segmentation, secure access controls, and traffic monitoring at the network level to prevent unauthorized access and contain potential breaches. Endpoint security solutions, such as antivirus software and device hardening, help protect individual devices. At the same time, regular patch management ensures that software vulnerabilities are addressed promptly. Regular testing, including tabletop exercises, failover tests, and simulations, is essential to identify vulnerabilities, evaluate response plans, and improve redundancy measures. By incorporating redundancy strategies, organizations can reduce risks, minimize downtime, and ensure the continuity of their critical business functions. Testing high availability, load balancing, and failover technologies is critical. It assesses the ability to remain operational during heavy workloads, component failures, or scheduled maintenance. Load testing incorporates specialized software tools to validate a system's performance under expected or peak loads and identify bottlenecks or scalability issues. Failover testing focuses on validating failover processes to ensure a seamless transition between primary and secondary infrastructure. Testing monitoring systems validate effective detection and response to failures and performance issues. Robust testing practices allow organizations to ensure that high availability, load balancing, and failover technologies effectively fulfill their purpose to minimize unexpected outages and maximize performance. That's it for this lesson. In this lesson, we discussed various redundancy strategies, including high availability, power redundancy, vendor diversity, and defense in depth. We reviewed the importance of testing high availability, load balancing, and failover technologies.